So, good morning, and this one is the first session of the new topic now, and the name of the topic is a calculus of variation. Weightage of the topic is a 7 mark in the final examination. It's a very small topic, hardly we require maximum 2 sessions to finish this topic. Okay, so probably half of the part we are going to finish it today, and the remaining half in the next session. So that about this topic. So again I will tell you the top in this topic hardly you have to remember one formula, only one formula. On the basis of that formula you will solve each and every example there. So just a minute. So in this topic mainly we are going to solve the problems of the type y equal to fx. Okay, our aim is to find throughout this topic the curve y equal to fx which pass through the 2 points, say x1 y1 and x2 y2. See, I will say x1 y1 and x2 y2. We are given 2 points in the plane, and we have to find out the equation of curve passing through these 2 points. Now we know there are infinitely many curves pass through this point, because yes, straight line is only one, but we are seeing the curve can be of any type then. So many curves possible from given 2 points. Our aim is to find one of the curve for which this integral value is extremum. This integral of a function of x, y dash dx should be extremum. So that is our aim. Now, right now I know definitely it is not clear to you what is exactly the nature of the problem. If I give a simple example here, like suppose we are interested to find the curve which passes through x1 y1 and x2 y2, so that the length of that curve is a minimum. So what should be your answer? What should be the curve for which the length of that curve passing through the two given point is a minimum?
So straight line.
Yes, obviously a straight line, correct. So the best curve that you have is a straight line like this, whose length is a minimum. If you take any other curves like this, if you take the curve like this one or like this one, so obviously these curves have, like I will say this is a C1 curve, this one is a C2 curve, and this one is our C3 curve. Okay, so C3 curve starts with x1 y1 and ends at here. So obviously the length of that C1 is a minimum out of all these three curves. So this is just by observation, but now we are going to prove mathematically that the straight line is a curve for which the length is a minimum there with the help of a calculus of variation. So use of this topic is actually there are many problems which are already famous, like Brachistochrone problem, this length of the curve, minimum surface of revolution. Okay, so all these examples, yes, we can solve it by the calculus of variation. Now let me come to the nature of the problem first. Let me understand. So throughout this topic we are going to find the equation of curve. What is our answer always? That is curve y equal to fx, which is passing through the two given points. These points are always given. We may give on a particular points or a general point. Okay, where it may be said that x1 y1 and x2 y2, or it may be said as a 0 0 comma 1 1. So it should pass from 0 0 and 1 1 like that. So whatever the case, so we can find a general solution also, or a particular solution also, that particular curve at that particular points. Now whatever this integral is left, this integral is known as a functional. This is a functional. Why it is a functional? Because it is integration of some function again, and that function is not a function of x only. This function is of f is a function of x, y, and y dash. What is that y dash? Y dash is a obviously dy by dx. This is another notation for y dash. So y dash is a dy by dx there. So this is the notations only. So this is the type of the problem that may come. It become more clear when we start the examples there. Okay. So that about the introduction for the topic here. Now these are only the theory part. This is only the theory part throughout the topic. First of all, this is the definition of a functional. So when we say functional, you should know it is an integral. This integral is known as a functional. Next, this integral is extremum. Now extremum, the word extremum is nothing but it is a minimum or maximum. Minimum or maximum, that is the extremum. Okay, so the value of this integral or value of that functional is a minimum if it satisfies this equation. If it satisfies the Euler's equation, this is known as a Euler's equation. Euler written this condition. There is a proof for this statement in the textbook. Those who are interested, they can see the proof. Proofs will not come in the exam. Just you should remember that integrand f should satisfy the Euler equation, and if you solve this Euler equation for f, our aim is to find out fx by solving this equation. So if we solve this Euler's equation, which is a partial derivative like dou f by dou y minus d dx of dou f by dou y dash equal to 0, and we obtain that fx, that becomes our answer. Definitely for that fx, that integral is a minimum or maximum there. That is an extremum we are saying. So this is the most important formula for you. So each and every example of this topic you can solve it by Euler's equation only. Dou f by dou y minus d dx of dou f by dou y dash is equal to 0. There is one more shortcut equation. It's mainly used whenever f is a free from x. Whenever given integrand f is a free from x, that means f is not depending on x. F is a function of y and y dash only. Okay, or only y dash, whatever. But f should not depend on x. Then we can use this equation for simplified calculation. The equation is f minus y dash into dou f by dou y dash is equal to constant. F minus y dash into dou f by dou y dash is equal to constant. Okay, so definitely you will not get any idea about this topic by the theory. Yes, once we solve few examples like minimum surface of revolution, then Brachistochrone problem, and smallest path passing through the 2 points. So all these examples, once we finish it, then you will get the idea about the use of this topic, calculus of variation, where it actually used. Okay, so come to the examples now. So then only you have the clear idea about how to use this Euler's equation. So I'm showing you the first example. The first example is on the screen. The question is, find the extremal of this function integral x1 to x2 y dash square upon x cube dx. Y dash square upon x cube dx. So this is the functional. For this functional, we have to calculate extremal value. Now Euler said that this integral we have the extremal value provided it satisfies that Euler's equation. So we should start a solution like this by Euler's equation. By Euler's equation, yes, anyone can tell me the equation?
Del f by del x
Dou f by dou x.
minus del by del x into del f by del y.
No, I think you everything whatever you are saying, each and everything is not correct. Yes,
So del f by del y
yes, it is a dou f
Del f
by
by
dou
del
y minus,
minus d by dx
yes,
into del f by del y equals to 0.
dou y dash is equal to 0. Okay, so you
Yes.
should yes, definitely after solving few examples you will remember this equation. So what we have to see, what we have to say here, this integral will be a extremum. That means the value of this integral is a minimum or maximum only if that integrand f is satisfying this equation. What is the value of f here? What is f?
So y dash square
y
upon
dash
x cube.
square upon x cube.
Correct, very good. Y dash square upon x cube is the value of the f given. So integral f dx is always given. So whatever this is f. So sorry, my mistake is here. I again written that wrong thing here. It is a dou f by dou y, na? Dou f by dou y minus d dx of dou f by dou y dash is equal to 0. That's the formula. So can you tell me what is the value of dou f by dou y? We will differentiate f partially with y. Remember, first of all, this f is a function of x, y, and y dash. Okay, treat all these three are the different variable. Even though we know that y dash is a dy by dx, that means y dash depend on x, y also depend on x. That is okay. But here we are taking partial derivative, and when we differentiate f partially with y or partially with y dash, you have to treat other as a constant. For example, when you calculate dou f by dou y, x and y dash are a constant there. When you calculate dou f by dou y dash, x and y are like a constant only. So this is like a notation of a partial derivative. So let I ask 110, tell me the value of a dou f by dou y. What is the dou f by dou y from this?
Good morning, sir.
Yes, good
So
morning.
one by x cube.
How 1 by x cube? Whether f is a depending on y. Is there y term appear in the function f?
Y dash.
It is y dash, na? Y dash square upon x cube. So f is depending on y dash and x only. F is independent of y. So what is the dou f by dou y?
So I'm taking that, sir, y by x, 1 by x cube as constant, sir, because
1 by x cube is a constant, okay. But what is the dou f by dou y?
yes,
Yes.
sir. So y dash by cube,
Not
y dash
correct.
cube
Not
by
correct.
3, y dash cube by 3.
Anyone who, yes,
But
138.
zero, zero.
138. Yeah.
Zero, zero,
Zero
zero.
is the answer. That's one straightforward. Because we are differentiating f partially with y. So x and y dash are like a constant, and each whole f is like a constant, and derivative of a constant is a zero there. It is a big zero there. Yeah. So minus d dx will be as it is. Now, what is the value of a dou f by dou y dash? Yes, 110. Tell me now. Dou f by dou y dash.
1 by x cube,
Okay.
y dash by 3 by 3.
Not correct. How you are saying? You are not able to differentiate simple variables. Y dash square, you have to
Difference,
differentiate with y
2
dash
y
only.
dash, 2
2y
y
dash,
dash.
that's one.
Y dash
Yes,
by
sir.
2y dash
Yes, sir.
upon x cube. That's a simple
Yes, sir.
differentiation. Is it?
Yes, sir.
So, first of all, we calculated dou f by dou y. As f doesn't depend on y, the derivative is a 0. Dou f by dou y dash is a 2y dash upon x cube. That's one. Now, our aim is to find out y equal to fx. What is the ultimate aim of all these questions? We are always finding y as a function of fx as a curve, the equation of curve. That we have to find it. And for that curve, the value of integral is always extremum. The value of integral is always extremum. So we have to remove all the derivatives and all these things, and we should get y. So what should be the next step? Anyone? What should be the next step there?
Differentiating by x.
Uh,
Sir.
if you differentiate, it is of no use, because if you differentiate again, you have to integrate. We have to find out y. Integrate. Okay, that's the best. Correct. Integrating both sides. First of all, this minus sign will merge there, and if you say integrating with respect to x, okay, with respect to x, obviously. So this derivative or integration is anti-process. So we get 2y dash upon
Equal to
x cube is equal to, yes,
0.
not 0. Integration 0 plus c, the constant of
It's
integration.
constant will come.
C.
No?
Okay. So I will write this side now. So 2y dash becomes cx cube. So y dash will become c by 2 x cube. Is it? So what should
Yes,
be
sir.
the next step to get a y now?
So
Again
y
integrate,
dash is the
Again,
integrate
we will
both
again
sides
again integrate.
integrating with respect to x
with
only,
y.
because y dash is a dy
X
by
x.
dx. Y dash is a dy by dx. So integrating with respect to x, y is equal to, yes, what is the integration of x cube?
X to the power 4 by 4.
Plus
Plus c.
C.
Plus c.
plus
Plus
c1 now. I will
c
take
by
new
c.
Yeah,
constant.
C1.
Okay.
Yes, sir.
Already c is used. So this is your final curve. You can keep this as answer, or I am writing like this. I will say c by 8. C by 8 as a c2. C2x4 plus C1, because C is some general constant. C is a constant. C by 8 is again a new constant. So we just denoted C by 8 as a C2. So y equal to C2 x raised to 4 plus C1 is a curve for which the value of this integral will be extremum. Okay, that is a minimum or maximum there. Okay, so that is the end of the question. We got the curve y equal to fx for which the value of integral is a extremum. Any doubt? Remember, your answer can be in any of the form. If you write this as a final answer, that is also correct. This is also correct, or this is your answer. So this is also correct. So both are the correct answers there.
Sir, I have a doubt, sir.
Yes.
Sir, in the second answer you gave, why is the 2 and 4 not in the denominator?
2 and 4. So I'm saying that one now where C2, I'm writing C2. It is a C2 is a C by 8. I considered this one. Okay.
Yes, sir.
Is that clear? If someone writes
Yes.
right instead of C1 and C2, suppose y equal to a into x raised to 4 plus b, that is also correct because these
Yes, sir.
constants are the notations only what we are using. Okay.
Yes. Thank you, sir.
Yeah. Any other doubt? Anyone? Throughout the topic, we are doing only this part only. All these remaining examples are like this only. So all these examples are already solved, and these are all with solutions. They are uploaded on TMILMS. So this is you will see this is a solution that's given exactly what we done. So this is the f that we are given, y dash square upon x cube. So dou f by dou y is 0. So this Euler equation become only d dx of dou f by dou y dash, because this dou f by dou y is 0. We already seen. Here, d dx of dou f by dou y dash is calculated as 2y dash upon x cube, integrating with respect to x, and again integrating, we have this as a final answer. So this is the so multiple ways of writing the answers are there. Here is one of the answer written. You'll observe this is one of the answer. If someone writes this answer like this, what we done previously, like c1 upon 8 x raised to 4 plus c2, then that is also correct. If someone write this answer whatever I written on the previous slide as a c1 x raised to 4 plus c2, okay, then that is also correct. Remember, we written like this, c2x4 plus c1, so this is also correct. So if you write c1 to the c2 and c2 to the c1, it doesn't matter because these are general constant. We don't know what they are arbitrary constant. What is that value? Someone writes the answer like y equal to ax raised to 4 plus b. I already said this. This is also correct. So there are equivalent answers. I'm going to say there are all equivalent answer, but the variables cannot be different. Variables will remain the same. The constant notations can change, but variables remains the same. Any doubt there?
No, sir.
Okay.
Sir, hello.
Yes.
So why limits are given here?
The
We
limit is actually this is general points were given. We are calculated the curve passing through the general point x1 y1, x1 y1 and x2 y2, and because of that we get answer in two arbitrary constants c1 and c2. Suppose this particular limit given, suppose you are given passing through 0 0 and 1 1, what we can do it, we can find out that values of c1 and c2. Okay, right now we got a general path, general curve passing through the any 2 points x1 y1. So these limits for the integral are these ordinates x1 to x2, x1 to x2 of f dx. Okay, so these
yes.
limits always given there. You will come to know the use of limit in the next example. Okay.
Okay.
Oh. So here is the second question, and you will observe now here also the limits given, but it is not written x1 to x2. Instead of written 0 to 1. The meaning is we are going to calculate a particular curve now. We are going to find out a uh, particular curve passing through the point 0 comma 0, because x is 0, y is 0. Y of 0 is 0 means 0 0, and y of 1 is 1 means 1 1. So we are going to compute the curve which passes through 0 0 and 1 1, for which this integral is a extremum. Okay, so find the curve for which this function is extremum is word missing here. Okay, the question is incomplete. Find the curve on which this functional with this is the extremum. Is extremum. So that about the question here. So let us start. What is the Euler's equation?
So del f by del y
Hmm?
minus d by dx
Of,
into del f by del y dash
yes, correct, is equal to 0.
is
Now,
equal to 0.
what is the value of f here? So f is equal to
Y dash square
y dash square.
plus 12xy.
Okay, good, correct, thank you. So dou f by dou y now. We want the value of dou f by dou y.
12x.
12x is
So
the correct
12x,
answer, good. Minus d dx of
2i
dou f
dash.
by
2y dash.
2y dash.
2y dash
So next step.
integrate.
Okay, so that
Yeah,
is also okay. You can integrate, but I will
2y dash equals to.
I will simplify this first. You can integrate also. That is not wrong. So I will say d dx of 2y dash is equal to 12x. Okay, so this term on taken on the other side. Now integrating, yes, no issue. 2y dash integrating integration of LHS is a 2y dash. What is the integration of RHS?
12x square by
12x
2.
6.
square by 2.
So what is the value
Plus
of
c.
y dash?
So it will be plus
3x
c now
square.
again.
Yes,
3x.
Constant.
plus c. My mistake. Correct.
So
3x square.
6x
3x
3x
square
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 plus
plus
c.
c.
Just a minute. I will write it. C1. Okay. So this is a 3x square
3x
plus
square
Plus
plus
c1.
c.
c.
Again integrating.
Yes, sir. Y is equal to
Again integrating. Let I change the y is equal to. Yes. What is the integration?
x cube plus
3x cube
2.
by 3.
Square.
C1x plus C2.
Yes, sir.
Okay. So this is the end of the solution if the general question was there. Suppose the limit are written x1 to x2. This is the end of the answer. That is the curve for which the functional is extremum. That integral is extremum. But right now, this is not full complete solution. There is one particular points given. So let me use given x is 0 and y is 0. The first point we say y0 is 0. That is x is 0, y is 0. So this implies 0 is equal to, so 0, 0, that is C2. C2 is a 0. Is it?
Yes, sir.
So C2 is already 0 now. Also, x is 1 implies y is also 1. So that is also given x1, y1. So this gives us 1 equal to, we are putting here 1 is equal to x is 1. So 1 plus C1, C2 is already 0. So no need to write it. C2 is already 0. So 1 is equal to 1 plus C1. So what should be the C1?
0.
C1 is
0.
also 0. So we got particular curve. Thus, therefore, y equal to x cube only. Remember, the constant gone out because of that particular points, and we got a particular curve. Y equal to x cube is a curve which for which the integral value, this integral value is an extremum. That is a minimum or a maximum there. And that is the end of the answer. Sorry, end of the solution there. If you have the doubt, yes, you can ask.
So the two values are used to find the like constants.
Mhm.
This.
These constants we replace in the general solution here. This solution. This is general solution. This is the general curve passing through arbitrary point x1, y1 and x2, y2. But we want that particular. So this got particular by these particular points. Now this curve y equal to x cube is a passing through 0, 0 and 1, 1 also. You'll observe
Okay. Okay.
this curve will pass through these 2 points only. Any doubt?
No, sir.
Okay. So I'll move to the next question then. Here is a before that, yes, this solution is given on TMI-LMS. Already uploaded there. So this is the f given. So all the values calculated. This equation reduces here. 2 times integration done, and this we already observed. And then both the constant goes to the 0 and y equal to x cube is the final answer we are getting. We already seen this
Sir,
was
they have taken at y dash to y double dash.
correct. Anyway, you can go now. So I'm
Like,
saying if you differentiate, then you have to integrate twice. and the same thing we done only. Okay, so multiple ways are there. Remember, in mathematics, your understanding is important. Means you whether you can solve the problem in any different way, that you have to think. No, don't follow whatever I am writing or I am giving only. You should think logically, and you can find out the best path. Okay, the best path by which the example becomes simple. Okay, so choice is your. This is also correct. Whatever we done, that is also correct. If you find a third method your own, that is also correct, probably, provided that is logically correct, then okay. So you can do it in your own way also. Okay, so this is one of the favorite question of I think IMU, because it's repeated number of times. If you take uh, suppose a 5 question paper, you will find at least in 3 of the question paper this question was asked out of 5. Okay, so the question is find the shortest, or prove that the shortest distance between 2 points in the plane is a straight line. Shortest distance between 2 point in the plane is a straight line. That we have to prove now mathematically. Okay, not yes, you can say easily that yes, the shortest distance is between the 2 point is always a straight line, that I know, but let me prove it with the help of a calculus of variation. So for this there is a need that integral is not given. Okay, that integral which we have to extremize, that is not given, that we have to construct actually. So I'm going to start with 2 points, because we have to find generally the curve passing through the 2 point. So if I say we have the 2 points, say the point A, which is a x1 y1, and the point B, say x2 y2. Okay, and our aim is to show the curve which is passing through these 2 points is a straight line for which the length is a minimum. Okay, the distance is minimum. So we are going to take any random curve here. Let I draw some random curve like this. This is the curve C. On that curve C, again to construct the equation, for the distance, we are going to take two neighboring points on that curve. I am going to say there is point x comma y, and another point, say I will say that is a x plus dx comma y plus dy. So remember, xy is a general point, and x plus dx and y plus dy is another neighboring point, where just small unit in x is added, that is the dx, and in y that dy is added there. So these are the 2 points we are taking on the curve. Now whenever that is the case, you will observe the horizontal distance. If you plot this horizontal and vertical lines there, this horizontal distance, what will be the horizontal distance? Anyone? If the coordinates are x, y, and x plus dx, y plus dy, what will be the horizontal and vertical distance here?
dy and dx.
Correct. So vertical distance will be the dy, and the horizontal distance will be the dx there, because of that coordinates whatever we are given. So when dx and dy are tending to 0, they are very small. What will happen? This hypotenuse there, that acts like a straight line. Let I write that small length between these 2 points, x plus dx, sorry, xy, and that x plus dx, y plus dy as a ds. ds is a small arc length of that AB. So by Pythagoras theorem, what will be the equation we get it here?
ds under root dx square plus dy square.
ds square is equal to dx square plus dy square. Why we are getting this? We are assuming that dx and dy are very small, they are tending to the 0, and when they are very neighboring point, that arc act like a straight line. Because we're taking very close points, two close points. And now this is a small arc length, very small arc length of the length AB. So we want the entire arc length S. So before that, let me find out the formula for arc length S. So we are going to divide this equation throughout by dx. If we divide this equation throughout by dx, I can rewrite this equation like this: ds by dx bracket square is equal to 1 plus dy by dx bracket square. So dx square is a divided throughout. Dx square is a divided throughout. So ds by dx will become square root of 1 plus dy by dx bracket square. Now this dy by dx, I'm going to write it by y dash, because we know that we use that notation in calculus of variation. So I'll say 1 plus y dash square. Ds by dx value is a 1 plus y dash square. We want actually only arc length s. So first this equation can give us the value of a ds as ds is equal to square root of 1 plus y dash square into dx. Cross multiplied this dx there. Can anyone tell me what should be the next step to get complete arc length s? Suppose this length AB is s. Length
Integrate.
yes, integrate.
Integrate.
Very good. So this is the term known as a rectification. Actually, whatever we are learning right now, this is the process of rectification, and this is the formula of arc length s. That is a rectification formula, and arc length s is integration from x1 to x2 root of 1 plus y dash square dx. So root of 1 plus y dash square dx, this is the formula of arc length. And now our aim is to minimize the arc length. So this is the general arc length of any curve passing through the AB. Our aim is to, what is the curve? Now the question is changed from this one. What is the curve for which the curve passing through x1 y1 and x2 y2, for which that arc length s is a minimum? This arc length is a minimum. That means this s is a distance is a minimum there. Is it clear first? This derivation,
Yes, sir.
yes, you have to remember there, or you remember this entire derivation. No need to write in the exam again. You can start with here also, because this is standard formula of arc length. You can say as arc length s is given by this one. So you should write like this directly. Okay. Now our aim is to minimize this value of s. So what is the Euler's equation?
Dou f by dou y minus d by
Yes,
dx dou f by dou y dash equal to
minus
0.
ddx of dou f by dou y dash is equal to 0. But instead of using that equation, I'm going to use the another equation. The reason is already I written one note. When
Independent of x.
integrand is a free from x, okay,
Yeah.
here f is equal to, here that integrand f is a root of 1 plus y dash square, is it? So which is a free from x, which is free from x, means this f does not depend on x. The variable x is not there. Therefore, Euler's equation, by Euler's equation, we are not going to take the first Euler equation. I am going to write the second, and that equation is f minus y dash into dou f by dou y dash is equal to constant. So this equation we are going to solve it, because this gives us a simple calculation. Remember, you can solve this problem by first Euler equation also, and you will get same answer. But if you want to simplify your calculation, whenever f is a free from x, better to use a second form. Better to use a second form. Any doubt up to here? Now a very simple thing is left. Just to replace the values of f there, and we get the answer. Is there any doubt? I will erase this side. Yes, you can tell me the value of f now. What is f? Root
Under
of
root 1
1
plus
plus
y
y
dash square.
dash square minus y dash. What is the dou f by dou y dash? This is the important.
1 by 2
Yes, 1 by
plus 2
2 root
1 plus y dash square
2
y dash
derivative of 1 plus y dash
into
square is 2y dash
yeah 2 y
Two.
dash.
is equal to constant. Okay,
Yes,
is
sir.
equal to constant is written. So you'll observe few of the things gets cancelled. First of all, this 2 gets cancelled. This 2 gets cancelled with this 2 and cross multiplied. Now we are going to cross multiply. So this become 1 plus y dash square minus y dash square and this square root. Okay, I will keep as it is, otherwise root of 1 plus y dash square is equal to c, just cross multiplied. Again few simplification, y dash square gets cancelled. So if you observe, we get here, what is our aim? Our aim is to solve it for y dash. So can anyone tell me what should be done to get a y dash value?
First cross multiplication
Yes,
and then
correct, cross multiply, or I will say root of 1 plus y dash square will be 1 by c. Okay, because we are interested in getting y dash. So this is a cross multiplied, or I hope it's clear to you. So squaring both side, 1 plus y dash square become 1 by c square. So y dash square will become 1 by c square minus 1. Any doubt up to this step? Is there any
No,
doubt?
sir.
No, sir.
No.
The
Okay.
1 by c dash, and that can be another constant like
Yes, that's
c1.
very good. This
So
is
it
the
will
very
come y equal
important thing
to
that you
Yeah.
should.
c1x.
Yes, whatever entire RHS, or I will write one more step actually. So if I write like this, I'm writing with this color now. So y dash, I'm writing taking square root on both sides. 1 plus c square minus 1, square root of 1 plus c square minus 1. Now this gives us y dash is equal to m. What is m? M is this square root, where m is equal to this one. Okay, where m is that under root, because this is entire some constant. Root of 1 plus c square minus 1 is some constant. Na? Is it clear?
Yes, sir.
Yes, sir.
So
Yes, sir.
integrating now, the last step, integrating. What will be the equation?
Y equal to mx plus c.
Yes.
Straight
And
line.
now don't think this c is that with that previous c. This is new c, or you can take alpha also, mx plus alpha. And what is that equation? The equation of a straight line. So thus we proved that arc length is a minimum. Arc length is a minimum only when that curve is a straight line. That curve is a straight line, and that's the proof. That's the proof of having the shortest distance between the 2 points in the plane is a straight line. Okay, and that's the use of calculus of variation. This calculus of variation gives us the extremum values of the functionals. Mainly functional is an integral. It is not only function. uh, Getting the maximum minima of a function you learnt in 12th standard, it is by calculus again. You will get by derivative again. In partial differentiation you will learn getting maxima minima of function of more than one variable, but here we are calculating maxima minima of a functional, not function. Okay, so this is the value of integral will be the minimum or maximum provided that y equal to fx for this curve only. So this is again solved by both way. If you see the solution I given, so in the solution whatever I'm given here is both way. So this first part is given by the first formula, whatever we done right now. This is f minus y dash. By this formula we got y equal to mx plus c. Okay, we just seen. So this is the way you can proceed. Okay, answer is correct. You can check in between if there is a mistake, but yes, definitely we done it right now also. There is another way, yes, by first equation. If you want to do it by first equation, then also your answer will be the same, that is a straight line only. So the answer will not change, but generally the calculation becomes more simple by this form only. Whenever f is a free from x, whenever f is a independent of x there. Any doubt?